Hi, in this tutorial we are going to solve a question related to radical stability. The question asks us, rank the following radicals in order of increasing stability. Let's start from the first radical. The first radical, here the radical carbon is here, and it is connected to 1, 2, and 3 atoms, so 3 carbons. So we have 3 neighboring carbons. So A is a tertiary radical. And in the second option, the radical carbon is here, and it is connected to 2 carbons, and this is a secondary radical. And the third option, we have radical here on this carbon, and it is connected to just 1 carbon, so it's a primary radical. But when we analyze the next neighboring bond, it's a pi bond, so this is a primary radical plus an allylic radical. So what do we mean by allylic radical? So let's erase this part, and if you look at the structure, we can actually write a resonance form by combining this electron here, shifting it here, and shifting a pi electron here, and shifting the other pi electron here. So we can have a resonance form, and in the resonance form, the radical is shifting here on this carbon. And if you check this one, this is a tertiary radical. So basically, allylic radicals can have resonance forms, and we know that resonance make radicals, carbocations, and the other species very stable. So for that reason, C is going to be an allylic radical. So we have 2 resonance forms. In the resonance forms, primary radical and tertiary radicals. Let's move to option D. Option D is the radical here is on the carbon, and we have 2 neighboring carbons. So this is a secondary radical. But the radical is on a carbon having a pi bond. So this type of radicals are called vinylic radicals. Okay, so vinylic radicals are extremely unstable. This is a known fact. Even though this is a secondary radical, the radical is on a carbon having a pi bond. Let's move to the option E. Option E, we have the radical here on this carbon, and the neighboring, we have just 1 neighboring carbon, so this is a primary radical. So let's summarize. We know that tertiary radicals are more stable than secondary. Secondary radicals are more stable than primary. And we know that vinylic radicals are least stable, and allylic radicals are the most stable. So based on this, we can conclude that C is the most stable radical, and second is A, and then B, then E, and the least one is the vinylic radical D. Thank you so much for watching the video.